Portable telephones were first sold in the country of Salmania in 1990. During 1990, the number of units sold is 160. In 1991, the number of units sold is 240, and in 1992, the number of units sold is 360. In 1993, it was noticed that the annual sales for my geometry sequence, with the first term being 160, the second being 240, and the third being 360. So we're asked to find what is the common ratio of this sequence. So we know that the first term given is 160. The second term we're given is 240, and the third term we're given is 360. So we're trying to find the common ratio between each term. So what number is multiplied by each number in order to get the next number. So in order to do this, we just divide each number by the previous one. So in this case, we divide 240 by 160, and we find that this is 1.5. Similarly, we divide 360 by 240, which gives us 1.5 as well. So we know that based on this, we know that the common ratio for this given trend, or just this given geometric sequence, is 1.5. So now in part B, we're asked to determine how many units will be sold in the year 2002. Well, in the problem we're given that in 1990, a total of 160 units were sold. And based on this, we're trying to find how many units were sold in 2002. So if we do the math, between 1990 and 2002, there's a 13-year difference, which will actually become our n, because it shows the amount of years after the 160 units. And we know from part A of this problem that our r equals 1.5. So now, based on all this information, we can actually plug everything into our geometric sequence formula and solve for the amount of units. So U13, because we know our n is 13, equals to U1, which is 160, times 1.5, which is our r, to the power of n minus 1, which we know n is to be 13, minus 1. So now if we multiply all this correctly, we're given a U13 that equals 20,760 units. So what this means is that in the year 2002, which was 13 years after the year 1990, 20,760 units were sold based on the ratio of R of 1.5. So now in this example in part C, we're asked to determine in what year does the number of units sold first exceed 5,000 units. So we're still going to use our geometric sequence, but instead of making it equal to, we're going to have to make it greater than, because we're trying to determine when more than 5,000 units were sold. So let's start out by setting there are 5,000, and we try to determine when they sold more than 5,000 were sold. So we do our less than, and now we just plug in everything we know. So U1, we know it's 160. We know our R to be a 1.5, and we know our N to be undefined for now, because we don't know the year yet, and then it's n minus 1. So now we're trying to solve for n. First off, we can get rid of 160 by dividing both sides by 160. So we're left with 31.25 less than 1.5 to the power of n minus 1. Now from here we can just get rid of exponents by doing log. So log 31.25 less than n minus 1 log 1.5. So now we can now divide both sides by 1.5 in order to get rid of this 1.5 and isolate the n. So that's what we're going to do. We're going to divide both sides by 1.5, get rid of this, and then we're going to input this into a calculator in order to determine what is log 31.25 by log 1.5, and based on this we get 8.48 less than n minus 1. Now all we have to do to solve for n is add 1 to both sides. So 9.48 is less than n. So what this means is that after more than 9.48 years, more than 5,000 units were sold, but we can't have a fraction of a year in this case. So we're going to have to round this up to 10 equals n. So what this means is that after 10 years, more than 4,000 units were sold. So what is 10 years compared to the year 1990? Well, if you count 1990, that will be 1999. So in the year 1999, which was 10 years after 1990, more than 5,000 units were sold. And now on part D, we're trying to find what is the total number of units sold between the year 1990 and 2002. So before we get further into this problem, we know that it's a geometric series because it's a sum. It's a sum of units sold between a certain margin of years. Now looking at the years, we know that it's actually 13 years. So we know that our n will be for this given problem, our n will be 13. And now all we have to do is just plug everything into our geometric series formula. So Sn, which n is 13, so S13 equal to U1, which is 160, times R, which we already know it's 1.5, to the power of n, which is 13, minus 1, all this divided by R, which we know to be 1.5, minus 1. And if we just multiply accordingly and divide accordingly, we should get our S13, which is the sum of the total units sold between the year 1990 and 2002, to be 61,958.24. But since we're talking about units sold, we cannot have a fraction. We cannot have a decimal number, so therefore we have to actually round up. So our actual answer would be 61,959 units sold between the years 1990 and 2002.